we're going to do now is we're going to play around with functions a little bit. We'll start with the parent function and then do some transformations. And just by seeing how the graphs are affected, this will help you start learning how to understand transformations of functions. All right, so let's start with just really simple quadratic. And by the way, this is at desmos.com, which is a nice, convenient online graphing calculator. So we have that nice parabolic shape as you'd expect. Now notice what happens if we just do plus 1 on that. Well, as you probably imagined, we have a vertical shift of 1 unit up. So we have a parabola, same exact shape as the parent, but it's shifted 1 unit up. Now let's do a shift of 1 unit down. So notice that the only difference is that it's minus 1 instead of plus 1. Up 1, down 1. Up 1, down 1. Sorry about that. Down 1. Okay? So you can see the difference, and it's just what happens when we subtract 1. That's the same as going down 1. Or if we add 1, that's the same as going, or the graph going up 1. Okay, so nothing too surprising there. What if we did something different? And so now look at what happens if I go x minus 1 and then I square that. So now minus 1 inside the parentheses is shifting 1 to the right. The parabola gets shifted 1 to the right. Now, what if I do inside the parentheses plus 1? Well, now the parabola gets shifted 1 to the left. And that's because, like, for example, if you plug in 0 for 1, or 0 for x, okay? So if I plug in 0 for x, well, then 1 squared is just going to be 1, right? And so that's why I'm going to have 1 over here as my y coordinate if I plug 0 in for x. Well, what if I plug negative 1 in for x? Well, negative 1 in for x gives me 0, and 0 squared is 0, and that's why I have the point negative 1, 0 on the line. All right, so to recap then, if I, within the function, within the parentheses, do plus, that's a shift to the left. And if within the parentheses I do minus, like I just did, that's the same as a shift to the right. Okay, now what if we did both? Well, you can imagine that if I do plus 1 now, I have a parent function of x squared, which is a parabola, shifted 1 to the right and shifted 1 up. Okay, what if we did minus 1? Well, then I have it shifted 1 to the right and 1 unit down. What if I did, instead of minus in the parentheses, plus 1? Well, now I have it shifted, the graph is shifted 1 to the left and 1 down. All right, so let's try a different parent. And let's just do x cubed. Okay, we don't need the parentheses, as you can see, but I'm going to just keep the parentheses for now so I can illustrate some other transformations. All right, so x cubed. Let's predict what would happen if I do x cubed plus 1. Well, you probably already know that x cubed plus 1 is just going to be the graph of the cubic parent function shifted 1 unit up. Okay, now let's do minus 1. Well, as you probably predicted, it's the cubic function shifted down 1 unit. All right, what do you think is going to happen if within the parentheses I do minus 1? Okay, right now, look, the graph is just the standard parent function, cubic parent function. Predict what's going to happen if I put minus 1 within the parentheses, which means minus 1 within the function. And sure enough, you probably predicted that minus 1 within the function is going to give me a shift of 1 unit to the right. How about plus 1 within the function? Yep, that's going to give me a shift of 1 unit to the left. How about plus 1 within the function and minus 1 outside the function, outside the parentheses? Yes, that gives me a shift of 1 unit down. So here what we have then is we have a shift of 1 unit to the left and 1 unit down. All right, now let's try something different, which is we're going to do a bracket, and then what we're going to do in front of the brackets is a negative. All right, let's understand what happened there. That is called an x-axis reflection, because what we've done is we flipped the whole thing in the x-axis. Okay, let me go back. Okay, that's without doing the x-axis reflection. Simple cubic function that is shifted 1 unit to the left and 1 unit down. Okay, now watch carefully what happens when I do an x-axis reflection. And an x-axis reflection is doing a negative of the whole function. You're taking that y-coordinate, whatever it is, for whatever x you plug in, you're going to get a certain y-coordinate. And you're doing a negative of that. Okay, now pay attention. I'm going to throw that negative in. Boom. Take the negative out. Boom. Throw it back in. Take it out. Throw it in. Take it out. Throw it in. Take it out. Okay, watch what's happening. Okay, we're flipping everything about the x-axis. So this point here that I'm hovering my mouse arrow over is the point -1, -1. Okay. Well, the point -1, -1, when I do an x-axis reflection, the x-coordinate won't change, but the y-coordinate will. And see what happened? The y-coordinate of -1 became +1. See that again. The y-coordinate of -1 became +1. All right, let's look at the other things. If this up here, right, in the right-hand portion of the curve, as you can see, that's going to go all the way up to -infinity. The y-coordinate is going to get huge. Well, now, x-axis reflection means that y-coordinate becomes very negative because I did a negative of it. Conversely, going back to the non-reflected function, this region down here that I'm hovering my mouse arrow over, it's very, very negative y-coordinates, right? As the x-coordinates get more and more negative, well, the y-coordinates get huge and very negative. But then x-axis reflection, watch what happens. All those very negative y-coordinates became very positive y-coordinates because I did a negative on them. And so the pattern then is that the whole graph is flipped about the x-axis. Okay? That is unflipped. This is flipped. Unflipped, flipped. Unflipped, flipped. Unflipped, flipped. The whole thing gets flipped over the x-axis. All right, let's look at a different thing that can happen, which is called a y-axis reflection. And this is what happens when you just turn that x into a negative x. Okay, watch this. All I did was turn the x into a negative x. Okay. X becomes negative x, flipped. Unflipped, flipped. Unflipped, flipped. Unflipped, flipped. See, we're flipping everything about the y-axis. It's like the y-axis is a mirror. And as I keep showing you this, you're going to see that it's exactly as you'd predict. Everything that was on the left is now on the right, and everything that was on the right is now on the left. Unflipped, flipped. Unflipped, flipped. Unflipped, flipped. All right, so that's how y-axis reflections work. So to recap everything we've done, we're going to just bring it all back to a parent, and it's all just going to be super simple. And we're just going to keep it really simple for a second. This is your good old parent cubic function. All right, you want to do a vertical shift on that. Okay, +1. You've shifted it up 1 unit. All right, you want to do a horizontal shift? Oh, let's do this. Okay, we've simply shifted it to the right. Cubic function shifted 1 unit to the right and 1 unit up. All right, those are just shifts, horizontal shift, vertical shift. You want to do a reflection on this, and for that I'm going to take the bracket out now, and now the bracket goes around the whole thing. Let's reflect it about the x-axis. Reflected, unreflected, reflected, unflipped, flipped, unflipped, flipped, unflipped. Okay, now we want to do a y-axis reflection. Reflected, unreflected, reflected, unreflected, reflected. All right, so hopefully this video just gives you a brief introduction into the shifts and reflections that we're going to be doing in section 1.7, 1.8. All right, see you in class.